Hello everyone, this is Deepak Chetri with the physics lesson on principle of moment and falling objects. In the class we have learned about torque, moment of force or moment of couple. So we used a formula torque is equal to force times displacement, where tau represents torque, F represents force and D the displacement or the distance between the objects. Now in case of couple, there is always two forces acting in a couple. So this F represents one of the forces and D is the distance between two forces in case of couple. And in case of moment of force, F represents the force which is applied on the free end of the object or movable part of the object, where D represents the distance between the point of application of force and the pivot. The principle of moment. The force applied to produce turning effect about a pivot is called moment of force. So that is about the moment of force, torque. So moment of force is calculated using force times displacement that we have seen already. Now the principle of moment states, the principle of moment says that the total counterclockwise moment is equal to the clockwise moment or total clockwise moment when the body is at equilibrium. So this one we will see with the help of a simulation. Let us look at principle of moment with the help of this simulation. We have got a bar here which is marked in terms of meters. So this is scaled graduated with the meter scale, and if you place a 5 kg weight on one side, so if we remove this support, let us see what happens. It produces a turning effect. So this turning effect produced by a force is called torque. So whenever there is turning effect produced by a force, it is called torque. Now if you remove this, it again goes back to its initial state. The balance state of the object, or when the counter and clockwise and counterclockwise movements are equal, or this is called equilibrium state. The balance state of the body is called equilibrium state. Now if we place a 5 kg weight, so it produces turning effect. Now let's place another 10 kg weight on other side. Let's place it by 1.5 meter. So this produces counterclockwise movement. So there are two types of movement here, clockwise and counterclockwise movement. So initially we placed 5 kg of mass, and then this was producing clockwise movement, whereas another 10 kg of mass was able to produce counterclockwise movement. Now here the turning effect produced is not equal. That is why the bar has not come to equilibrium state. Now let us look for some point where this bar can be balanced to attain equilibrium. Okay, let's try and place this at 1.25. Okay, it is still more. Now let's try it at 1. All right, so it looks like at this point, yes, so there is a green signal which shows that the bar is at equilibrium. So at this point the bar has come to equilibrium. So what could be the reason? When does this bar come to an equilibrium? It is, let us calculate now, this 5 kg of mass exerts the force of 5 times 10. 10 is the acceleration due to gravity. So it experiences, it applies or exerts the force of 50 Newton. And here 10 kg applies the force of 100 Newton, 10 times 10, 100. Now, what is the total turning effect produced towards clockwise direction? So that is tau is equal to F times D. So tau is equal to F times D. When you calculate, we get force of 5 times 10 is 50. F is 50, and we have got the distance of 2 meter. The distance from pivot till mass is 2 meter. So 50 times 2 is 100 Newton meter. So clockwise turning effect or clockwise torque produces 100 meter, and counterclockwise torque produces 10 times 10 is 100. We have force of 100 Newton, and the distance of the force is placed at a distance of 1 meter. So we have 100 times 1 is 100 Newton meter. So we got equal torque on clockwise and counterclockwise. So that is why the bar has come to equilibrium state. Now if you remove one of these, the turning effect is produced. The principle of movement states that total counterclockwise movement is equal to total clockwise movement when the body is at equilibrium. Similar to what we have seen in the simulation, we have got a metal bar here suspended at the point pivot or fulcrum, and we have two forces acting on that bar. Force one is F1 acting at d1 meter away from the pivot, another force of F2 acting at d2 meter away from the pivot. Principle of movement says sum of counterclockwise movement is equal to sum of clockwise movement. Then that is represented as tau CCW is equal to tau CW. Now here we have got force F1, which is 200 Newton, produces counterclockwise movement, and force of F2, 380 Newton, produces clockwise movement. And we are given the distance that force F1 is placed from the pivot, but distance d2 is not given. So we are asked to calculate the d2. So firstly, which force will turn the bar clockwise? Okay, the solution is the force F2 will turn the bar clockwise, and force F1 will turn the bar counterclockwise. Now where should we place this F2 to have equilibrium? So now let's look at the solution. So firstly, counterclockwise movement is produced by F1. So that is CCW, the torque is given by F1 times d1. Torque counterclockwise is given by F1 times d1. Torque clockwise is given by F2 times d2. So d2 is this one, F2 is the 380 Newton. And the next step we have is F1 times d1 is equal to F2 times d2. That is just to calculate the missing variable. We have got d2 here is equal to F1 times d1 divided by F2. And now let's replace the value of force and the displacements. d2 is not given, so we are keeping it separated on the other side. So F1 is 200 Newton, d1 is 5 meter, and we have got F2 380 Newton. Now when you calculate that, we get d2 of 2.6 meter. So that which means if we place this F2 380 Newton 2.6 meter away from the pivot, then the bar is going to come at equilibrium. Now let's look at the falling objects. Whenever any object falls on earth through air, it experiences two forces. So two forces come into effect on any object that is falling through atmosphere. One is weight of the object caused due to gravity, which acts downwards, and other one is air resistance force that acts against the weight. Free falling object. So what type of object do you call as a free falling? An object that falls under the sole influence of gravity is called free falling object. So if object is falling only under the influence of gravity without any other disturbances, without any other factors, then we call that object as to be free falling object. So there are two important factors about free falling objects, and they are free falling object do not encounter air resistance. So there is no air resistance on free falling object. And second factor is on earth, free falling object accelerates downward at the rate of 9.8 meter per second square. So the value of acceleration is 9.8 meter per second square. Therefore, any object falling on earth will accelerate at the same rate of 9.8 meter per second square. Then the upward force which acts on the falling object is called drag force. So there is upward air resistance force acting on a falling body is called drag force. Then the drag force is calculated using 0.5 times d times v square times a times c. So that is 0.5 is a coefficient value given to get the exact number value of this drag force. Then d represents the density of air, v square, so v represents velocity of falling body, a represents surface area of the object, and c represents drag coefficient, so coefficient of the drag force. Then we have got two questions here. First question is, if you drop feather and marble from certain height on the surface of earth, which will hit the ground first and why? You are dropping a feather and a marble from certain height on earth in presence of air. And second question is, if you drop feather and marble from certain height in absence of air or in vacuum, which will hit the ground first and why? Let us look at the confirmation through video clip. This is a famous experiment conducted by Galileo. So what he did here is he placed a ball and some feathers inside a room at certain height, and both the feather and balls were released at the same time, exactly at the same time, and see what happens. Let us okay. So what did you observe now? This is in presence of air. A feather and the ball were dropped at the same time, and you can see the ball has already reached down to the ground, but feather comes slowly. Now they have done the second experiment. This is second part of experiment where they removed all the air from the room. They evacuated the room and created the room as a vacuum and released the ball and the feather together, like what they have done during the first experiment. You can see that in this case both the feather and the ball descend exactly at the same time. Now let's come back to the questions again. Now what would happen to the first question? The marble will hit the ground first as it experiences lesser drag force compared to the feather. Marble has less surface area and it's heavier than the feather. Therefore, it experiences lesser drag force compared to feather. Feather has a greater surface area and also it is lighter, which floats in air due to drag force. The second one is both the marble and feather will hit the ground at the same time as the drag force is absent for both. So in this case, the second case, when there is no air inside the room, so both of them are striking the ground at the same time. So that is all for today. So thank you and have a nice day and stay safe.